1,000 here?
No, 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 no. Question mark is a question mark. The 1,000 is because the moisture content. So here is 1,000 because I am simply, it's a way of finding the mass fraction for the oxygen in air.
In the table itself, though, you actually use
No, my table is a little bit different.
Okay.
Because that is attached to my particular solution.
Okay.
This is one example of one possible table. My table is slightly different. There might be any other table, but essentially what you're going to have is a table that where you put your masses that go in, depending on your basis of calculation and your methodology of solution, and your masses that go out. The fractions cannot be equal because the compositions are going to change.
Yes.
But the total masses that have to go in of each one and out of each one, no, not the masses of each one, sorry, the total sum of the mass has to stay constant.
Yes.
There's chemical reactions, so the only one that keeps its own mass intact is the nitrogen. Everybody else changes because the oxygen gets eaten up. The water receives some addition. The CO2 gets created and the propane gets annihilated. So there is some, of course there's changes because chemical reaction, but the total amount of mass that goes in has to be equal to the total amount of mass that goes out. And what is going to make this table change is depending which type of base of calculation you like best. Remember in mass balances and those things, you always are told to pick up your own base of calculation that you like. And different people like different bases of calculation.
So assuming 1 kilogram of propane is consumed, this is how everything should balance.
Yeah.
Well, it's not going to be 1 kilogram of propane.
Oh, sorry. No, I'm sorry. Here this question mark is not does not exist.
Yeah.
This is our base of calculation. Yeah, 1 kilogram more.
Or 1 gram more.
Oh,
And so
okay.
based on all of the math that comes as a result of that basis, you can figure out based on the heat input to the system you want, how much propane you're actually combusting, and subsequently how much.
So this one is the other way around. Sorry, I got a little bit confused here. Yeah. No, the question mark is here only. Sorry.
Okay.
I'm sorry. I used, this is my basis of calculation, 1 kilogram or 1 gram. The only thing I don't know is that I need to figure out how much of this air comes in. That's all.
And how did you figure that out?
One second.
We know how much air is coming in though.
No. Wait. 1 second. I added a variable that I didn't need because I was thinking of the second part of the question, which is everything gets multiplied by a common factor because of the fan. That's what that question mark is. Okay, but that you can figure it out with the fan. Here is only the temperature. So I made the solution. I made the solution a little bit more complicated than it looks like. For the first part of the proportion, all you need to figure out is this. Okay, which is the amount of air that you need per kilo of propane. That's a ratio. If I burn a kilo of propane or a gram of propane or whatever, I get a fixed amount of CO2 produced, a fixed amount of water produced, and a fixed amount of oxygen consumed. That's fixed because I chose 1 kilo of propane. What I need to figure out is how much air do I need so that I get the temperature to where I want it. That I don't know how much it is, because if I want high temperature, I'm going to get little air. If I want low temperature, I want to get lots of air. That's what I'm answering here. And that's simply going to go into these equations here. So I replace those things there, in and out, and I'm going to have this unknown here all over the equation, but it's going to become the only unknown.
Why did you set it up this way when the air is what's fixed? Like we are taking in a set amount of air in the system, and it's the propane that's going to vary.
I set it up this way because some people like to think like that. I didn't set it this way. It's not this way in the spreadsheet.
It just seems confusing to introduce it this way when it's not the way the spray dryer is done. I'm confused.
All right. So then
We spent 45 minutes on this, and like we still have to do distillation today, and we're not any further. Like,
well,
I'm more confused. Like I thought I understood this before we started talking, and now I'm more confused about what's going on in the spreadsheet and like what we're talking about.
We're talking about stoichiometry combustion.
Yeah, which is really simple, and this made it really confusing. Like we had done this in our lab, and like it's energy in, energy out. You combust so much propane, you get so much water. You just make it balanced because the amount of water you make changes like your CV and stuff.
That's all there is.
But all this stuff that we've done, like I just found this very confusing for what I thought I already knew. And we only have 2 hours left in the session, we still have 2 distillations. So like what I thought was a simple question got like really out of hand, and now
Part of the advantage of a study period is we can go a little bit above and beyond and try to
There's like other exams to study for too, right?
So let's move on. Let's go back to the spreadsheet and.
Okay, so I will close here the combustion, and I think the important thing is that is exactly what you said. It's just a heat and a mass and energy balance of a combustion process.
one thing though, could we get units on like some of these things? Like
Yeah.
Let's pull that up.
Yeah,
And
that
the
for
key
sure.
thing to remember is X amount of energy is going to be required to heat X amount of dry air and water vapor, including that which is produced. Okay?
That's all. And in many processes, this generation of energy is a very important part of the cost of the process. And depending on your source of energy, being able to quantify that is important. Okay. So what, let me add here.
We're not quite up.
Oh, it's even logged me off from there. So I think I'd rather connect my computer and then get things going from my computer. Because that also I cannot save it. So here it gets saved and I can post it and everything. So let's connect what corresponds to the that guy.
The next one, degrees Celsius.
Well, it was all disconnected. So this one is the one that belongs to that. But the whole system had turned itself off.
Okay.
No, it's not finding it.
Just because lack of. Good man. That's what you have on your I thought Robbie was pretty good.
Oh, yeah. Yeah. I was watching
Why do people
And now it's on.
Yes.
No, there is a problem with the thing.
Okay, I thought you were shaking your head at me.
Judge or board?
Last time,
Yeah, we got it.
let me see if
All parts of Europe. Turkey, Belgium, Turkey, Belgium.
He said, you know what? I actually, yes and no. It's exciting. And I'm going to post up because I'm not going to fear of stopping going crazy for a temperature.
This kid dead. Don't look at me.
You ever see the video? Cool guys who are
Cool guys who are?
It's like a video by The Lonely Island.
Oh,
Anyways, telling me I was walking with me.
oh,
The side screen.
It wasn't the same, but it was great.
I can try the VGA, maybe it will work.
Jump in the river. Like, yeah, and it's all silly. So we're gonna have like a lot of quick dry stuff. So water going on me and then shower and sing it's gonna be intense.
So, I guess sometimes all technology works.
We're in front of the
So, I just put in, okay, so,
distilleries.
That's why you're really going.
Embrace that Scottish roots.
Trying to get tired. Figure out what your is.
Yeah. Get to a fist fight and bring it up ass there. You'd be able to go over to like London and see all
The Scottish are a little bit
the second half yeah, so that's grade 10. Walking up to the store. And this random guy grade school, he's like, you suck. Next guy walks by and gives you a cigarette.
so, let's focus on the,
All right, here we go back in.
so, sorry, this is my own spreadsheet, so, I'm going to change this thing here. I'll remember to fix this right.
Yeah, and kilopascals as well.
Oh.
Speak up.
In the lab, we calculated the dry air
giving or known the wet bulb and the dry bulb temperature, because we know the air velocity. So what we're saying in this, we wouldn't know those temperatures.
No. You know those are knowns.
Okay,
Those
so
are
why
well
can't we-
knowns.
So here, for
Find the gyre
example,
the same
you
way.
know you have your air in the here you have your air of your room, let's say. You have your wet bulb temperature and your dry bulb temperature.
So if you didn't want to, a lot of groups use the difference in wet bulb humidity coming in, the humidity coming out, minus how much water they assumed was evaporating based upon the feed rates to determine how much moisture was generated and then how much propane. It's a really messy calculation because you have a lot of variability in how we measure that with the wet bulb temperature, and the amount of water coming in with the feed is so massive. It dwarfs the amount made.
Oh,
from-
that method.
Yeah.
Why do we all get such good marks?
Say that again. I want to make this. I want to understand this very clear because when I heard someone commenting, say that clearly again.
From the beginning? Okay, so I was wrong. Okay, so in the lab, we knew the velocity of the air,
Yes.
as well as the dry bulb and wet bulb temperature. So we found the humidity, and then we figured that's how much dry air was coming in.
How much? What?
Air, dry air?
Yes.
Okay.
Yes.
So now we also know the wet bulb and the dry bulb temperature, and I assume we're going to know what the velocity of the air is. So why can't we just figure out the same way for the dry air? Why do we have to go?
We are trying to. No, what we are getting here is the rate is how much propane do you need.
Yeah, but we did that by
How?
back calculating and then just.
How? How?
How did we calculate the amount of propane?
Yes.
We figured out how much heat was in the air, how much heat got gained by the air, and then divide that by the heat of combustion of the propane.
How did you calculate the heat that was in the air?
We figured out the temperature difference as well as we added the latent heat vaporization for the water.
So you calculated the enthalpy of the air.
Yes. But this,
That's exactly the same.
but now you're adding so many more variables. You're saying that
What
dry
made-
air.
what
You're
made
saying
more
that we don't
variables?
know dry air.
No, I'm just saying you don't know the proportion between the air and the propane.
So why can't we just calculate the same way we did in the lab?
Of course. So long as you don't use only the water as your calculation. So if you tell me that you're going to estimate the amount of propane based on the moisture content of the air and not on the enthalpies, on the overall enthalpies, because a group tried to calculate it just based on the change in moisture. And the amount of water is so small, and the error in the water, in the wet bulb temperature is so big, that you would get wild variabilities in the amount of air. So that method, no. It's impossible. If you calculate the enthalpies, that's fine. You have all that information.
All right,
But-
let's add some units.
So this is exactly the same. It's just the enthalpy, it's the same enthalpy balance as you did in the lab. You have the temperature in, you have the temperature out, you have the enthalpy in, you have the enthalpy out, you find the difference in enthalpies, you figure out how much propane you need to do that. But you have to calculate the enthalpies including the moistures, not without the moistures. That's all. But if you don't know the amount of propane, how do you know the moisture? If you don't know the moisture, how do you know the exact moisture? How do you calculate the enthalpy? If you calculated the enthalpies without knowing the moistures, and if you base your moisture only on the wet bulb temperature, then the moisture that you calculated at the end was only a very rough approximation. But if you use that only to calculate the enthalpy, then maybe it's okay. But you run the risk to even get negative moisture. Because if you take the moisture of your air out and just subtract the moisture, you have to make sure that you have not ended up with less moisture than you started in and stuff like that. No? Good, okay. So, but you can do it like that. It's the same, exactly the same. It's basically how much